One of the things required on this aircraft, even if we're not flying, is to update the FMS database every 28 days. I came to the airport today to do that, and I thought I'd take the opportunity to show you the power up of the aircraft from a cold, dark cockpit as we see now. So what I'll do is just run through the checklist, and I'll take my time with it. Normally I would do it much faster than you see in this video, but for the purpose of explanation, I will pause at various stages and just explain what the relevant check involves. So the first thing we do is check the circuit breaker panel. That's behind the co-pilot seat. Make sure that they're all in. Check the safety equipment is on board and the fire extinguisher. We check the fire discharge handles are in and vertical. There are three there, the left engine, the right engine and the APU. We check the hydraulic pumps are turned off. The nose steering switch is off. The landing gear lever is down. The flight spoiler lever is retracted. The engine run switches are off. Now this is the gear pin holder, so before we would fly, I would go and remove the landing gear safety pins and I would put them in that holder. We just put it there so that we don't forget the gear pins. Move it out of the way. Next thing we check is the slat and flap lever. It's currently at slats in and flap 0, and then we come down and check the ram air turbine and emergency gear extension handles are both down. And at this point we turn the battery master on. You can see there this small light is illuminated. That's because I have external power fitted to the aircraft. If we were outside for a normal trip, I would be starting the APU, but inside the hangar we just use an external power cart. So when I hit that battery master, you'll see that two of the flight displays are illuminated and also the standby attitude indicator. It's just in the alignment mode. So the next thing we do is just run through some of the checks. The first one is the fire test.
Left engine fire. Right engine fire. APU fire. Smoke. Gear bay overheat.
The next one is the oral warning test.
Oral warning test 1. Stall.
Emergency descent.
No takeoff. Left engine fire. Right engine fire. APU fire. Smoke. Cabin altitude. Gear bay overheat. Left reverser unlocked. Right reverser unlocked. Normal brake fail. Gear. Auto throttle. Auto throttle. Altitude. Minimums. Minimums. Cell call. Cell call.
So that just gives you an idea of some of the sounds we could hear in flight. The next one is the lamp test, and what that does is illuminate every light in the cockpit so we can make sure they're all working. And because I'm in the hangar, some of the checks I won't do, but I will talk about them. One is the nav lights would now come on, and we would then turn the wing transfer switch to auto before starting the APU, but we're not starting the APU in the hangar, we're using external power. So I will press this external AC button, and that will bring the aircraft electrical system fully online. Now at this point you'll see the other flight displays illuminating and the remaining FMS units powering up also. So when you first power up like that, you have to wait a few minutes while the aircraft goes through a series of self-tests. If you look at that stab indicator, the cross, when that cross disappears, I can do the hydraulic pump test. It just takes a few minutes. Okay, what we can do now is select the hydraulic display page, and I'm going to test the hydraulic pumps, the electrically operated ones. This aircraft has several pumps, some are engine driven and some are electrically operated. So we're just going to test the pump number 2B, pump 1B, pump 3B, and 3A. The aircraft has 3 separate hydraulic systems. And the next test is the stall test. This aircraft has a stick pusher and a stick shaker. So we'll just run through that test. And basically what that means is that the aircraft can detect if it's approaching an aerodynamic stall, and it will vibrate the control yoke to get your attention, and if you still don't take recovery action, the aircraft will do it for you by pushing the stick forward. So we'll just complete that test. So we're just looking for that indication. The next thing is the RAT test, the ram air turbine test. And that's the indication you're looking for. At this point we can turn on the inertial reference systems. You can see that the artificial horizon has no indication on the left and the right side. You won't get any indication until the IRSs have aligned. So I've turned them on, and what we now have to do is initialize the position. And we do that by going into the FMS to the pos init button and loading the current position on all FMSs. If we then go to the position sensors, the IRS, you can see it is going to take 6 minutes to align at this point. Now I can't really do anything more inside the cockpit, so this is the time when I would step outside and do an external walk around of the aircraft while the IRSs are aligning. When they have aligned, you will see that we have attitude and heading indication on the instruments. So while we're waiting for the FMS to align, I'll just take you through some of the diagnostic pages on the aircraft. This is the bleed air system, which shows you the APU and the high pressure and low pressure bleed extraction points from the engine, and also the plumbing lines to the wings for the anti-ice. This is the air conditioning, the hydraulic pump page, which we looked at earlier, the AC electrical. This aircraft is fitted with 2 generators per engine, plus we have an additional generator on the APU and a 6th one on the ram air turbine. The DC electrical page, the fuel schematic. You can see the fuel quantity there is 5,700 pounds. We have not refueled since our last flight, so that was the landing fuel. And the flight controls page. Now we also have an in-flight test page. But that's not going to give us much information while we're sitting here on the ground. 3 minutes remaining for the IRS to align. I'll just show you how we can transfer fuel in this aircraft. Up here is the fuel wing transfer. It's currently off. If I put it in automatic, the system will automatically keep the fuel quantity balanced in the left and the right wing. I can override that and I can conduct a manual fuel transfer. So I'm now transferring from the left tank to the right tank, and you can see the diagnostic is showing that. I could reverse that. And it's now flowing from the right wing into the left wing. You can see through the schematic that the APU is only taking fuel from the right wing. So if we're on the ground for an extended period with the APU running, you can develop a fuel imbalance. Now, the aircraft will take care of that itself, or you can manually just transfer as I've indicated here. The transfer rate is quite slow, so as you can see, the quantity on the right tank is just going down very slowly, and the quantity on the left is increasing slowly. Okay, so we've now got the IRSs aligned, and that has given us aircraft attitude and heading information. So at this point we can enter a flight plan to the FMS. We can either download one electronically or enter it manually. I'll put in a manual flight plan down to Melbourne, and normally we would have a series of waypoints, but I'll just put one in for the purpose of this demonstration. The next thing we do is go to the Perf init page. It shows the aircraft type, the tail number, the climb, cruise and descent profiles, the transition altitude 10,000 feet. In the US that's 18,000 feet, in the UK it's much lower. The speed limit of 250 knots below 10,000 feet, and we now put in the initial cruise altitude. At this light weight we could go straight to 47,000 feet, no problem at all. From the flight plan we will have average winds for the route. I'll just put in 270 degrees at 60 knots. When you get airborne, you can download more accurate winds, but that's just enough for the pre-takeoff stage. The basic operating weight, we've put in 2 passengers, 10,000 pounds of fuel. You can see the gauge is showing 5,700. They would actually match on a real flight. I've just put 10,000 in, otherwise we would get low fuel warnings. Cargo of 300 pounds, giving us a gross weight of 63,999 pounds. At this point, we calculate the takeoff numbers. And we do that by going to the takeoff page, selecting a runway. We'll go off 16 right, activate, takeoff. We now need to put in the temperature and wind, so I'll just select 25 degrees temperature, and the wind is 160 at 15 knots. It's a dry runway, and we're using 6 degrees of flap with slats out, anti-ice is off. Confirm. It now computes how much runway is required. You can see 2,832 feet required, 12,899 feet of runway available. Plenty of runway here. And these are the V speeds. V1 is the decision speed. V rotate is the point where we pull back on the yoke to lift the aircraft off the ground. And V2 is the most efficient single engine speed for climbing. So if we lose an engine on takeoff, we are aiming for this speed of V2. Now I'm going to bug that manually and just add 10 knots to that. So 116 plus 10 gives us 126, because that's our range of speeds to fly at in the event of an engine failure on takeoff. We want to fly at V2 up to V2 plus 10. Now at this point I can turn on the cabin power and the back part of the aircraft will come to life, and that takes about 6 minutes or so. At this stage I would be setting up my iPad with a flight plan and also these electronic flight books. And the reason I'm here today is to update the FMS database. You can see the database expires on the 25th of April. So I've downloaded the new one into that USB drive. We'll just insert it there, turn the power on. It takes a minute to initialize. And then we go into the data load on the aircraft. Data load, nav database, from the loader to FMS1. So that takes a few minutes, and then we repeat the process for the other two FMS units. So while the FMS is doing the database update, I normally come down to the galley area, make myself a cup of coffee and scout for the new goodies that the flight attendant has placed on board. She takes great care of us during the flight because I promised her that if I'm well fed, she will get a smooth landing every time. So as you can see, the database update has completed. It's now valid until the 23rd of May, so we can update the other FMSs. A similar process, just takes a few minutes per FMS. And the other thing I do while here is the paper amendments to the Jeppesen Airway Manual. We generally operate as a paperless cockpit using the iPads and the electronic flight books, but we do keep a full worldwide set of charts here as a backup.